My name is Gergely Brotigo, and today I would like to talk about supply chain problems in the OSS world. So, to begin, the most the best thing or the most thing that you have to be aware in the open source industry is the level of trust that you have in various things that you use or various people that you interact with. So, as as the previous talks went, trust is almost always a key point in what you're using. So people interact with each other, people use various tools, people build various tools that then people will import and use in various services. So I am an open source maintainer on the project called External Secrets. And External Secrets is a CNCF project which basically does the following. You have a store somewhere sitting, for example, a Bitwarden secret manager or AWS secret manager or parameter store or whatever, and you have secrets that you would like to sync into your Kubernetes cluster. In order to do that, you would use external secrets, for example, or vault provider or whatever, to sync those secrets inside the Kubernetes cluster into secrets and then use them accordingly. So we at external secrets need to be very careful in what kind of pull requests we accept from the community, right? External secrets is mainly a community-driven project. So people add providers as they see fit or as they use. There are over 20 providers or something like that in external secret now that can be used to sync up secrets into the cluster. And then there are updates for these providers, obviously. Things get outdated, SDKs need to be updated, or various new methodologies or new ways of syncing secrets come in. Then providers need to be updated. So we need to be very keenly aware of what happens in our part of the woods. And that's where supply chain attacks can arise from. So, for example, if we take one of the most recent attacks, it's one of the most brutal ones today, is this exit attack. If someone doesn't know it, executives is part of Linux distributions, and there was an issue where a person basically became maintainer of this library, and then through rigorous efforts, and I do mean rigorous, it was a plan in the making for over 3 years. So over 3 years of effort put into this. They bullied the person who was maintaining the library into accepting them as a maintainer. Not they bullied them, but they used bot networks and whatnots and fake emails and fake personas to tell the person who was maintaining the library to hurry up, to do the work, to maintain it, to please get on with it. And then this new person was accepted into the role of maintainer because of how much work there was still to be done. And this new person actually did the work. They provided solutions. They provided code, like real code, normal looking, working code. So they built up this trust, in the library. And then obviously as trust, as they acquired maintainership and the necessary rights, they started the attack. They added some binaries which were considered as fake binaries into the test part of the system. So it was testing compression and whatnot through these binaries. And these binaries actually were exploits. And this almost went into major Linux distributions because they bullied the distribution specialists or testers or whatnot to please update the library, please update, we have fixes and so on and so forth. And this bullying worked because people in the open source community are burnt out. They are tired, they don't want this stuff on their heads, and they just want to get on with their lives. So, as the XKCD saying goes, there's this one little dude, person who was maintaining this tiny library on which the world was standing. So they eventually got in the fix, and there was tooling in place that was doing some of the testing, but the tooling was flawed. The testing was flawed. They actually tested, or it actually passed. The test passed because they thought, the test tool thought, that if the library cannot be compiled, then it doesn't support this test tool. So they sneaked in a tiny typo, which made the C program fail in compilation. And the test tool was saying, "Oh, right, yeah, this doesn't support this test tool, so skip it passed." And this is unbelievable in so many ways. But thankfully, it was caught before it was released to all major versions, and it was reverted. But still, trust is a major component in the OSS world, and people blindly using any kind of packages out there is another issue, which is the polyfill, the next problem. Basically, the same thing again. People gained access to polyfill CDN and the GitHub repository, and they started injecting stuff into polyfill and to the websites that download polyfill through CDNs without any kind of vetting, yet again. And still to this date, it's September 26th, there are sites out there, there are literally hundreds of thousands of sites out there that use the wrong polyfill, they use the wrong CDN, they still didn't update, they still are severely suspect to this attack. And then, of course, even automation can have its flaws. For example, if people find out or figure out by accident or by other means what kind of library you are using internally, they might mimic the name of the library in a public way. And if you have automated tools, looking at you, Go imports, that will replace the right tool, for example, Go imports could easily replace errors built in package to package/errors, and people wouldn't even notice because it's a one-on-one infill. And even though package errors /errors isn't a nefarious library, it very well could be, and people wouldn't notice because they don't pay attention what they are importing. And this is what this attack exploits. Maybe there's like a single typo in the name, or maybe there's like a variation of it, but it can import the wrong library, and people need to be very keenly aware of what they import, right? And lastly, the biggest one is the CrowdStrike one. They actually released a paper recently saying that the issue was regex all this time. They were testing the regex with parameter counts on certain things, and it turned out that they didn't update this regex to look for updated the regex to look for the 21st parameter, but didn't update the parameter, so it was an index out of bounds error actually. With regex, they didn't test the right number of regex parameters. But still, how this could have been avoided is testing. They do say in the paper that they are now updating their testing frameworks, their testing practices. Why not earlier? Sandbox environment runs are very important for these libraries, for these type of things, or any kind of library that you are using, sandbox it. And ABM deployments or A/B or red, green, or whatever, green, blue deployments are very important, which means you don't distribute your new stuff to everyone at the same time. You limit it. You limit it to nodes, to certain people, that's AB. And then what can we do as OSS maintainers? Not that much, but automate. Bitwarden, secret manager together with external secrets now. You can use secret rotations like this, exposure mitigation. So basically, even if there is an attack, people still won't have access to all of the information. They will only have access to a tiny amount of information, and it can be rotated very quickly. Audit logs, least privilege access is very important. So your stuff can be accessed by anyone. And SBOM checks and rollback ability is also a very important one. S-bomb checks can be used to verify something is still, the same thing, and monitoring. And I would like to close this with last words. Be ever vigilant, and the wolf has to be lucky only once, while you have to be lucky all the time. And that's all. Thank you very much.